Good afternoon. This is a class on engineering thermodynamics, and the topic is PdV work, the most known work in the field of thermodynamics. This is this topic you will find in engineering thermodynamics, first year BTech courses. And mechanical engineering students also will find the same topic in their next semesters, second year or third year courses. They will find the same topic. PdV work, very interesting and very easy. All of you have some idea about this topic, PdV work, where P is pressure and V is volume. You just conceive say there is one horizontal cylinder and there is one piston. Within this arrangement, there is some gas inside the cylinder and piston is there. So the gas cannot move out of the cylinder. Say at some interval of time, at some instant of time, the entire system is in thermodynamic equilibrium. This is what? This is piston. Now let us assume that you apply a force on the piston in this direction, so that the gas gets compressed to some extent. So there will be some linear movement of the piston. Say say that linear movement is very small. It is delta x, okay, x, y, z, x. Delta x is the displacement, very small displacement. So you know that when the gas is being compressed, so pressure of the gas will increase. There is no doubt. But since the displacement of the piston is very small, it is a small quantity, delta x. Since this displacement is very small, so you can easily say that there will be no appreciable change in the pressure. Only there will be some decrease of the volume of the gas, but there is no change in the pressure. Pressure remains constant, and say the pressure remains constant at the value P for pressure. Initially it was P, finally became P. Finally means where? When? After the displacement of delta x. Right? Suppose the inner area of the piston, that is delta A for area, delta A is the inner area. Now question is, what is the work done here? Here you can see that some work is being done upon the gas. Means some work is being done upon the system. Okay. That's why this compression is possible. Unless and until you apply some work to the system, the gas cannot get compressed by its own. Automatic compression is not possible. Anyway, so we are providing some work to the system by applying pressure on the cylinder, on the piston. So, question is, we have to calculate here, means the problem is we have to calculate the work done. Work done, the basic formula of work done is what? It is force into displacement. Forcing in which direction? In the direction of the displacement. Okay. So here what is the force? Force is equal to that pressure P multiplied by the area delta A. So P delta A is the force. And what is the displacement in the direction of the force? It is delta x. So P into delta A into delta x is the work done on the system for that little change in volume. What is the change in volume? Let us suppose change in volume is denoted by delta V. So delta V is nothing but it is the product of the area delta A and delta x. Instead of writing delta A, you can write directly A also, because that area need not to be very small. Okay? In that case, you can directly write A. Suppose we are using A, not delta A. We are using A. Okay? Not delta A. It is the entire area of the piston. Okay? So A into delta x, that is the small volume, delta V. So work done we have got to be P into A into delta x, and A into delta x is delta V or dV. Write it dV. There is no problem. So P into dV, this is the work done, and this work done is termed as PdV work. In thermodynamics, PdV work. So for a finite compression, this was an infinitesimal compression. For finite compression from state 1 to state 2, from an initial state to a final state, what will be the work done? So in that case, you have to take the summation of all these small works. All these small work done, you have to take the summation. And you know that it's very easy to take the summation, you just integrate the expression PdV from state 1 to state 2. Means from initial state to final state. Okay. You integrate, you will get the result. Result is what? Work done. So this is PdV work done, and you know that to integrate this expression PdV, you need to know the relation between, means mathematical relation between pressure and volume. Otherwise, integration is not possible. You have to know the relation between pressure and volume. PdV is there. So, if relation between pressure and volume is known, then you can write pressure in terms of volume. Then within the integration sign, the entire expression becomes in terms of volume. Then you can integrate. Again, you can write volume in terms of pressure, and then you can integrate. Choice is yours. Okay. So the main thing is that you have to know the relation. For different processes, the relation will be different. This is known to you. For different processes, for different thermodynamic processes, the relation between P and V will be different. I am giving you an example. For isochronic process, means constant volume process, what will be the work done? Volume remains constant, then there will be no PdV work. Volume remains constant means dV will be what? 0. dV is nothing but change in volume. So for constant volume process, change in volume is 0. So 0 multiplied by any pressure becomes 0. Okay, so for constant volume process, PdV work done is 0. For constant pressure process, what is the relationship between P and V? Constant pressure process, that is isobaric process. Relation is what? Between P and V. P is independent of V. It is isobaric or constant pressure process. So P is independent of V. P is a constant. So since P is a constant, it can be taken outside the integral sign. So work done is equal to integration of PdV. In the next line you write P into integration of dV, and changes from state 1 to state 2, say. Then integration becomes V. So V2 minus V1, P into V2 minus V1, P into change in the volume, pressure into change in the volume, that is the integration. That is the work done for constant pressure process. Then isothermal process is also there. For isothermal process we know that PV is equal to nRT. This relationship is known to you. This is applicable for all the cases. Okay. So PV is equal to nRT, and since the process is isothermal, means constant temperature process. So right hand side nRT, that thing becomes a constant. T is constant, so nRT is also a constant. For a given amount of gas, N is constant, R is constant, R is universal gas constant. And since the process is isothermal, it's constant temperature process, so T is constant, so right hand side is constant, so PV is equal to a constant. So say that constant is denoted by C. So PV is equal to C, right? Then P is equal to what? It is C by V. So water is equal to what? Integration of PdV. Now you replace that P by what? C by V. Okay, C is constant. Take this constant outside the integral sign. Then within the integral sign, what is there? What is left? dV by V. dV by V. Integration of dV by V is nothing but log of V to the base E, exponential E. Log of V. So if you integrate from step 1 to step 2, result is known to you. It is log V2 by V1. C into log V2 by V1, and C is what? C is the product of pressure and volume. So you can write either C is equal to P1 V1, or you can write C is equal to P2 V2. You just check what is given in your numerical forms. If P2 and V2 are known, then write P2 V2. Then if P1 and V1 are known, then write P1 V1. It is your choice. Okay. So result is P1 V1 into log V2 by V2, log V2 by V1, or P2 V2 into log V2 by V1. Both are same. There is no difference. Okay. So you can see that everything is very easy. Just use simple logics. Then you can easily calculate all these things. Then one more process is there that is known as adiabatic process. For adiabatic process, what is the relationship between pressure and volume? You know this thing. It is PV, P into V to the power gamma is equal to constant. Where P is pressure, V is volume, and to the power gamma, that gamma is what? That is the ratio of specific heats, Cp by Cv. Specific heat at constant pressure divided by specific heat at constant volume. For air, gamma is 1.4. So Pv to the power gamma is equal to constant, says that constant is denoted by C. Then P is equal to what? C by V to the power gamma. Now P is known in terms of V. Then use this thing to integrate. Integration is what? Integration of PdV. So write P is equal to C by V to the power gamma. That means C into V to the power minus gamma into dV. Then in the next step, you take C outside the integral sign. So remaining thing is V to the power minus gamma into dV. Result will be what? Result of integration, V to the power minus gamma plus 1 divided by minus gamma plus 1. Then integrate from state 1 to state 2. So it will be like V2 to the power minus gamma plus 1 by minus gamma plus 1 minus V1 to the power minus gamma plus 1 by minus gamma plus 1, like that. And again that C is there, so you know all these things. Verbally this is not possible. You first multiply that C with the first one and separately with the second one. second term. For the first term, what is there? V2 is there. So where there is V2, you replace C by P2 into V2 to the power gamma. And for the second part where V1 is present, there you write C is equal to P1 into V1 to the power gamma, and result is known to you. Okay? I am just discussing here the procedure for the derivations. Okay? It's so easy. Then isoenthalpic process, throttling process is there. Polytropic process is there. Polytropic process is the same as this adiabatic process, mathematically, not physically. Mathematically, they are same. For adiabatic process, PV to the power gamma is constant. For polytropic process, PV to the power n is constant, where n is called polytropic index. Okay. So anyway, you just keep in your mind one thing, that before the calculation of PdV work, you need to know the relationship between pressure and volume. If this relation is not known, then integration is not possible. Okay? Whatever be given in the problem, you just try to find out the relation between P and V and then integrate. No need to keep in your mind the end results of the work done. Within seconds, this is possible to calculate. In rough, you can calculate. You can derive the required formula. No need to keep all this formula in your mind. Okay? That's so easy, really easy. Anyway, this is the end of this lecture. Thank you.